My goal today is to finish 16.5. I think that would be a nice kind of wrap up the package thing. And we're dealing with curls and divs, and want to basically do 3 things. Pretty much have covered them, but I want to do more practice. There's a lot of different versions of these kinds of questions. We're going to find, to start with, some curl and divs, and my first question is going to be that guy. We're then going to test if something is conservative, and whoops, and this time I will remember to call it the right guy. Won't the curl of the vector function f be the 0 vector, right? 0, 0, 0. And if that happens, it's conservative. And if it is conservative, we're going to get some more practice at getting the potential function. And then, although I don't have it here, I'm actually going to kind of show you why that can be used for a line integral in 3D. So, is there any questions before we get started? We're good to go. Okay, right, I picked this darn looking ugly one because I thought this one has got a kind of pseudo symmetry to it, so it may generate an interesting curl. I have no idea what that curl is going to be. I just made it like 10 minutes ago. So it might be ridiculously ugly, or we might get lucky and that it ends up looking kind of nice. So it's going to be I, J, and K. I won't do the colour scheme, it takes me too long to do that. The operator for the grad, and an x over y, a y over z, and a z over x. Now let's see what we get here. We'll do the I, then I'll take away the j, and then I'll add the k. Okay. So we will cover up this guy. And the derivative of this is 0. And the derivative of this, so what am I going to get? I'm going to get the derivative of this with respect to y is 0. Take away the derivative of this with respect to z is negative 1 over z squared, negative y over z squared. So you get plus y over z squared. Could have been worse. If you do the partial derivative of this guy with respect to x, you'll get negative z over x squared, take away 0. And then if you do this fella, you get 0, take away x over y squared. And if you take away a negative, you end up with an odd. So it looks like the answer is y over z squared. 2 negatives make a plus. That fella. And that fella. I'm not quite sure how I feel about that answer. It's got kind of symmetry to it, doesn't it? Looks like that guy doesn't have the x, that guy doesn't have the y, that guy doesn't have the z. Yeah. Okay. And then we'll do the div. Right, so what we do then is we do the partial derivative with respect to x of that guy, plus the partial derivative with respect to y of the second guy, plus the partial derivative with respect to z of the third guy. And that's because we call these guys P, Q, and R. Right, if you do this guy with respect to x, you get that.
I think someone's trying to get into class.
Oh, perfect. Give me a second. Right. Hey, this is working well. When people come in, you tell me. Perfect. I like it. This guy is what, 1 over z, and this guy is 1 over x. make sure that I've got everybody who's trying to get in. Okay, looks like we're good. So, I mean, that was me just a general made-up function. Are we comfortable about the process for calculating the curl? And then a pretty straightforward process for calculating the div. If this guy had been 0, 0, 0, wouldn't this have been a conservative field? The fact that it's not is fine, because I'm assuming that there's probably more functions in the world that are not conservative than there are ones that are. Right. I think for my next one, I'm going to just pick one at random from the homework. I want something with some, and this one's got something in it. This is a little bit more interesting. And this is a version of 12. And it's got a 0. It's got a cosine of xz, and it's got a negative cosine of xy. And actually, that is not how it is written. So look, that's how it's written. But me personally, I always turn these guys into that. So when I read the question, that's actually what I write down. And it's just an idiosyncrasy of me, but the way my brain works is I find it helpful to have placeholders for all three things. Have you noticed here that there's a missing I term? But it's easy to, well, you know what I'm like, how careless I am. Can you imagine that when I do the this piece here, that I might put the guys in the wrong place? Right? I might just say first guy, second guy, 0 or something. So that's the only reason. There's no great significance in this. So the curl of f is going to be I giant K. Those three guys. And lastly is 0, cosine of xz, and a negative cosine of xy. Okay, let's see what the eyes look like. If you do a partial derivative going this way, you're going to do negative cosine xy with respect to y. Well, that's going to get you a negative sign, so that becomes plus. So it's going to be a positive sign of xy. And you're going to get something else, aren't you? Aren't you also going to get a times x because of the xy bit? Subtract, and if you go this way, cosine gets you a negative, so two negatives make that a plus. You'll also get a sine of xz, but with respect to z, you get an x. So if you differentiate this guy with respect to z, you get negative the sine of xz times an x, which is that, minus the second guy. If you do this fella with respect to x, you end up with a positive sine of xy times a y. And going this way, you get nothing. Last one is this guy. If you do this guy as a partial derivative with respect to x, you get a negative sine of xz times a z, and going this way, you get 0. So the answer is x sine xy plus x sine of xz y sine xy, and I made a mistake there, but I can fix it, and negative 2 sine of xz. Ah, what's wrong with that middle term?
Should be negative.
Yeah, because of this thing. It's the first guy, take away the second guy, add the third guy in terms of ijk. Right, that horrible mess is the answer, I hope. Yeah, looks like the answer. What about the div? Well, if you do a partial derivative of 0 with respect to x, plus the partial derivative of that guy with respect to y, plus the partial derivative of this fella, you get 0, 0, 0, which is 0. God, I wish I had a good memory. I wish I had a good memory. In that video that I haven't put up online yet because I just didn't have, well, I tried to put it online and it didn't work, so I didn't have enough time to do it a second time, and so you'll have to wait later today to get it. I think they told us what a diff f equals 0, and I might be proved wrong here, but was it not called something like an incompressible fluid or something?
That's right, I think.
Right. So evidently that's important, that if the div is 0, you've got an incompressible fluid, which I think means, only by its name, not because I'm into physics, that if you've got a tank of water and you try to squeeze it, it don't happen very easily. You agree? It can't be compressed easily, right? Which I believe isn't that part of how pneumatic things work? That compressing a liquid allows you to create a lot of force. That's why you can lift very heavy weights using pneumatic lifts and things. I believe that. So evidently, diff f equals 0 gives you that. Have we done enough curls and divs to feel comfortable about the process now? Can I move on away from them? Or has someone looked over it and said, I'm not sure how to do question 6? And if you have that question, I'll do it now. Are the curls and divs good? Okay, let's move on then. So let's go testing for conservative fields. And I did one last time, so I'm going to pick one that's 0. I should be able to find a 0 in here. Well, somewhere. It can't all be nothings. Where are you hiding? Ooh, what's a good one? I've got one that I can see. Oh, there's a better one. Did I do question 12 yesterday? Because it vaguely looks familiar.
You did
No,
not.
no. Anyway, it's not the right one now that I'm looking again. I'm just searching through the answers to find a 0 one. And it's like everything else. You can't find one when you're looking for one. When you're not looking, they're all over the place. I know there's one down at the bottom, but I'd like another one. Oh, here we go. Double check that one. Yeah, this is question 8. And we're going to check if this is a conservative field or not. And it's e to the z, 6 in x e to the z. So if I want to check if it's a conservative field or not, don't I just need to prove that it's a 0 vector? So I'll find the curl and we should be good. We have I, we have J, we have K, we have this guy, we have this guy, and we have this guy. And I just have enough room to fix it. I forgot that row. There. So if we cover this fella up, we are going to get the derivative of this guy with respect to y, which is 0. Take away the derivative of 6 with respect to y, which is 0. If I do the middle one, the derivative of this guy with respect to x is e to the z. Take away the derivative of this guy with respect to z, which is also e to the z. And if I do this one, the derivative of 6 with respect to x is 0, and the derivative of e to z with respect to y is 0. And there we go. It's conservative. So you really just find the curl and prove that it's 0, 0, 0. I mentioned this list last time, but let's do it again. Can you imagine I got a question where I did the first piece and it was 3x, and the question was, is it a conservative field or not? We're over. Agreed? I don't need to spend any time on the other two, because if that's not 0, who cares what the other two are? It won't be conservative. Let's find another conservative one. That one went quite quickly. Our vector field is 16xy, 8x squared plus 18yz, and it finishes with that guy. Okay, let me just pause for a minute in case anybody's turned up late. No, we're good. And 16xy goes here. 8x squared plus 18yz goes here. And 9y squared goes there. Okay, let's do the first one, the i's. You differentiate this guy, you get 18y. You go this way, that's nothing, that's 18. So 18y, take away 18y, that's a good start. You do this with respect to x and you get 0. You do this one with respect to z and you get 0. And you do this one with respect to x and you get 16x. And you do this one with respect to y and you get also 16x. So a perfect conservative field. We're good. Conservative field, curl is 0, 0, 0. Well, let's return back to this one and find the potential function. Basically step 3. Well, if you look at this fella, the relationship is that delta f will be that, which means the partial derivative of x, y, and z will be 16xy, 8x squared plus 18yz, and 9y squared. So the gradient of f will be the value big F. So we have little f of x is 16xy. Partial derivative with respect to y. And last but not least, you get that guy. Now for each one of these, we then essentially integrate with x, y, and z. And then, with a bit of luck, we'll put the whole thing together and we'll have the potential function. So in this question, if you integrate with respect to x, you get a power rule. So you get x squared and you get that fella. Plus an arbitrary constant that doesn't have an x in it. Then you go to the second one and you integrate it, this time with respect to y. So this guy gets you 8x squared y, and this guy gets you also a power rule, and 9 y squared z, plus a arbitrary constant that doesn't have a y in it. And then you do this fella with respect to z, you get that, plus an arbitrary function that doesn't have a z in it. And then you kind of look at this, you look at these, and you look at this, and you try and figure out some function that has all the pieces. These two guys and these two guys actually looks very familiar now. Are we cool on that function? How we got the potential?
Could you check the waiting room again real quick?
Thank you. A moment. Okay, I think I got that person in. Thank you again. Yeah, this is working well. The new Zoom, for some reason, has got, well, since I'm distracted, let me show you one of the new things that the new Zoom has got. I can now do clapping hands, thumbs up. I love that. That joke was so funny, I'm crying. That joke was a surprise. And happy birthday.
I'm sure it's had this for a minute.
Say that again.
I'm pretty sure it's had this for a minute now.
Okay. I'm not sure what you said. I think you said, I think this has had this for a minute.
Yeah, like I don't think it's new.
Oh, it is new to me. So maybe I had the old version of Zoom and you've all had the new version for ages. But I updated to Zoom 5 because it told me to. And it's one of the reasons I'm having problems telling when people are now coming in. And Aaron is giving me a sarcastic cry. That doesn't count. Okay, we need a joke. I need a joke. Anybody got one? James, you must have a joke. Come on. In your entire Submariner life, you must have been told one clean joke.
No, not really.
That's the joke.
Okay. Let me think of a topic then.
I got a quick one.
I tell you. You got one, Jason? Go for it.
Yeah, what do you call a fish with no eyes?
Or something. I don't know.
Yeah, it's fish.
Okay. Right. I've got to tell you this joke. It's really, really bad. So I'm probably going to get a whole load of crying eyes. It's that bad. You're crying with laughter. That's what I'm going for. This Scottish couple wanted a baby, and they tried and tried, and they just weren't lucky. Except one day they finally got a baby. But the only thing that was born was the head. But it was intelligent, and they loved the baby. And they brought it up, and it went great. And in Scotland, you reach 18, you're allowed to drink. And so he got to 18, and his dad says, I'm going to take you to the pub. I'm going to have a pint of beer and show you around. So he picks his son up, and he walks to the bar, and he goes over to the bar, and he puts his son down on the table, and he says to the barman, give him a pint of beer. The barman looks at him and says, well, how am I going to do that? He says, he knows how to drink. Stick a straw in his mouth, give him a pint of beer, and he's good to go. So the barman says, okay, I can do that. And he gave him it. And a miracle happens. After the head drank the first pint of beer, his torso grew back. And the head says to the barman, give me another pint of beer. And his arms grew. He says, get me another pint of beer, whole body. Everything grew back. And he's dead excited, and he's saying to his dad, Dad, it says it's a miracle. Look what this beer has done. I've got my body. I've grown the whole thing. And he says to his dad, I'm going to go home and get some clothes now. I'll be back in 5 minutes. And he opens the door, and he walks out, and he crosses the road, and a bus kills him, stone dead. So do you know what the moral of that story was? You should always quit when you're ahead. Brenda got the surprise. Aaron's crying. I'm getting pretty much, I got thumbs ups.
The other moral of the story could be that if you're a short person like me, just drink beer and you'll grow taller.
I wouldn't advise that as a medical process. God, I know I'm homesick, so I'm going to do this as well. I had a really good friend back in Scotland, and he was a small guy, and that's the only reason this came to me. And he used to drink too much, which is bad enough. But unfortunately, he was a mean drunk. There's different kinds of drunks, but he was a mean drunk, which means he wanted to fight once they got drunk. And the only problem with fighting is that if you want to be a mean drunk, try and be 6 foot tall and good at fighting. Don't be 5 foot tall and be really bad at it. Because all he did was get beat up all the time. And we tried to protect him. So when we were in the group that would, we would socialize together, and he got drunk, and he would try and pick fights with us, and we wouldn't have it. You're right. He is ugly. I totally agree with you. I don't know why I never thought of that. And you would just join in. And sometimes that would work and it was fine. But then other times we couldn't protect him. And you'd see him the next day with a big black eye. And we'd say, what happened? And he says, I got into a fight. And we thought, oh yeah. And we said, have you ever learned that when you get drunk, you end up in fights and you always lose and get beat up? And have you ever, made that connection? And do you know what his answer was? Stupidest answer in the world. You're right, but I still like drinking. That was it. He'd made no attempt to try and change his behaviour. Have you ever met people that are just dumb and know they're dumb and still do dumb things, even although they have already experienced the consequence of that dumb thing over and over again? Do you know in the olden days, they would just get killed off by being eaten by tigers? Right? Darwin would have taken care of that gene pool pretty quickly, right? But in today's world, you can still survive and function and still be dumb. And I'm not talking intelligence dumb, because he was an intelligent guy, I'm talking about dumb in behaviour. And I don't know where that came from, but it was a good story back home. I'm going to have to go back to Scotland and meet him.
There are a couple jokes towards the bottom in the chat.
Oh, we have some jokes. Ah, right. If here goes. Imagine if Americans switched from pounds to kilograms overnight. Do you know what would happen? There would be mass confusion. Yep. My dog is getting neutered right now. I guess he passes. Oh, no. No, sorry. That one you'll have to read. Okay, I stopped myself just in time. Okay, let's return back to what I'm actually getting paid for, which I do like doing, is math. So, proving something is conservative isn't that much different from one, isn't it? You just get the curl, and if it's 0, 0, 0, you're good to go. I want to do more of 3 then, where we find the potential function. So I'm going to just find a function that I already know is conservative. So I won't do the curl bit. I'll just focus now on the little f bit, right? The potential function part. So let me find another guy. There's always one, isn't there? And let's see if I can find him. Okay, here goes. This is a version of 19. This is the function. That just means it's the same guy as this one. This fella, right? Oh, can I change this question? Can I tell you that it is a conservative field, and you can check that out? And if you do the div of this thing, you will end up with 12 over x squared plus y squared plus z squared. Now, the reason I'm just telling you that one is I do not want to find f. Let me show you the problem. To get f, one, I have to integrate this mess. Do you know, I've changed my mind yet again. Let's go for it. At least I'll do one of them, right? How would you integrate that? What technique would you use?
That's a U sub.
It is. Since I probably need a lot of room, I'm going to do it over here. I want you to think of y and z are just numbers, right? They're just constants. So it's really 2x over x squared plus 4, right? That's kind of what it's like. So what would the u sub be?
X squared plus y squared plus z squared.
Now, when you differentiate, technically, I guess it's a partial derivative. Don't you just get 2x? And the crossover and the isolate. Oh, actually, this is quite nice looking. Because what you get is essentially 2x square root of u, 1 over 2x du. Everything cancels, and you get that guy. Oh, this is nice. Are you happy about 1 over square root becoming a negative a half power? So you add 1 to the power, and then you divide by the new power, so you get 2, because dividing by half gets you 2, which means you get 2 square root of u, which means you get 2 x squared plus y squared plus z squared. And there is our f. And I am now going to do something really cool. I didn't know it was going to be so pretty. If I start with fy and I start with fz, aren't these functions symmetric? So if you know the answer to one, shouldn't you be able to make a sensible prediction on the other two? In this particular example, would it seem reasonable that they end up being the same answer? Even although the math may take you slightly different variables, the destination takes you to the same location. Technically, that is with a function that doesn't have an x in it, plus a function that doesn't have a y in it, plus a function that doesn't have a z in it. Now, that is the right answer for this question. Pretend for a minute this was 2x ugly square root. Wouldn't this be 2y ugly square root? And this would be 2z ugly square root. So if you can get away with it, always think about symmetry if it's possible, because it will reduce your workload by a third, right? At least a third, maybe 2/3. Which means I can now tell you the potential function. A remarkably nice answer, considering what the ugly bugger looked like. That is such a cool question. So to finish with, because you can imagine, we've done a couple, but you can imagine the finding the potential function f, right? We've done a few examples, so hopefully you can do that. Let's finish with how would you use a conservative field to find a line integral in 3 dimensions? Now, remember we did, oops. We did this guy. Wasn't that essentially a line integral in 2 dimensions? Right.
Should we take roll now?
Oh, great idea. Yeah, do that one, right? Can you also remember that we did fellas that looked like this, which were double integrals, but didn't we do the f at the end, take away the f at the start? Remember that guy? Fundamental theorem. Actually, I should only have one fella there. So I am going to do a line integral of a 3-dimensional vector field with a sky C. Right. And it's going to be a conservative field. And C is going to be in terms of a parametric curve. Let's say that guy. And it's going to go from there to there. And make it 1. Easier. Right. That would be quite a difficult question. Except Since it is a conservative field and it has a potential function, don't we just evaluate the potential function at the end of the curve and the potential function at the beginning? So in this case, oops, try that again. At t equals 0, which is the start, you get e to the 0, which is 1, sine of 0, which is 0, and t is 0 is 0, so that's the start guy. And at t equals 1, a bit messier, but I can try my best. You get e, not very pretty, the sine of 1, 1. And where's that nice guy I did a minute ago? So remember this one that we got the potential? Let's use him. So the potential function in the question that we just did a few minutes ago is that guy. So if you wanted to know this fella, so you can imagine in 3D you started at one point and you went along this curve to the end. What would that line integral be? It would be the value of the function at 1, 0, 0. Take, oops, wrong way around. The value of the function of e sine 1, 1. Take away the value of the function at 1, 0, 0. And since that's the function, it's 2 lots of the square root of e squared sine squared of 1 plus 1. Take away 2 lots of 1. So if I know it's conservative and therefore it has a potential field, can I find the line integral passing through that vector field? This is a 3D vector field. All I need to know is the start and finish points, and that horrible mess is what the answer would be. That is very often considered the work done in passing through a vector field. Now, this horrible curve up here, couldn't it be any horrible curve in the world? As long as you have a start t and a finish t, you'll get 2 coordinates. The end coordinate take away the start.